Hello, and welcome everyone. Nice to see y'all. Hello, Bakersfield, California. I see you. Hello to everyone from all over the world. Good morning, good afternoon, good evening, good night. Happy Friday to most of you, and happy Saturday to all the early morning owls. I see some folks from India. I want to give you a special shout out to all our India viewers. I know the past week or two or three even has been pretty rough over there with COVID, so I hope you're all staying safe. I hope you are about to enjoy a decent weekend, and hopefully you get a break from some of the challenges out there. All right. So to get all started, if you joined us last Friday, we had an amazing session with Eddie Jowd and Andrea Griffiths around some of kind of the fundamental whys of open source. Why would you want to consider bringing open source into your company, or why would you consider contributing to open source as a developer? Today, now that you're already kind of hyped up to dive into open source, we're going to tackle some more practical steps and how to do so securely. So to that end, I'm going to introduce today's guest, Will Bartholomew. I am Will Barr everywhere on the social media. So, Will, welcome today.
Thank you.
So, Will is a product manager who is focused on security products and has long been involved in the software supply chain. So, Will, can you tell us a bit more about what you're going to go through today and how to uh, integrate open source securely into your projects?
Yeah, absolutely. So today, it's demo days. So I have a demo heavy session where I'm going to show, how GitHub security features can help make your use of open source more secure. And we're going to look at, why that's important and, just some of the ways to, structure how you think about that. So I think, with that, let's jump in. I'm also joined by Justin Hutchings, who's the Director of Supply Chain Security, who's going to be in the chat, helping answer questions as we go along. So I'm super excited about this. So, I wanted to kind of start with the why. And you'll see from this, this is analysis from the GitHub data science team. And the key takeaway, even if you ignore the numbers and the dates, the number of vulnerabilities has been pretty stubbornly correlated with the lines of code of open source for years, and that tells us that this isn't really a matter of if you're going to have to respond to a vulnerable open source component, but really when. And if we look at kind of the year over year of dependency alerts, I'll be talking a little bit more about that feature. There's a 39% increase in the number of alerts that we've sent out to active projects. And so knowing how you're going to respond to those, features you can use from GitHub and processes that you can put in place to help detect, protect from, and respond to those vulnerabilities is really important. This is something you want to think of ahead of time, and so you're not trying to react without kind of having a plan in place when it happens. And, something I wanted to kind of talk about before we, dive into some of the specific features is, there's countless frameworks and standards, mainly targeted at information security professionals to guide how you think about security. Not just open source security, but security in general. And I'm going to be demonstrating how some of the GitHub features contribute to these different security functions. Specifically today, I'm going to be focusing on the identify, protect, detect, and respond parts of this particular framework. And I'm not going to go into security frameworks in any depth, even this particular framework. This is one from the National Institute of Science and Technology. It's the cybersecurity framework. This is a demo day, so I want to focus on kind of showing you real things. But I wanted to tie these demos back to this because I think it's really important that we build up a common vocabulary between business people, information security people, as well as developers, so that we kind of know that we're talking about the same things and we know what tools are going to help us at what part of the security life cycle. And it's kind of important to note that, I'm really going to be focusing on the security of your open source today. There's other steps that you should be taking to kind of improve the security of your projects. Speaking of which, if I have one ask for you, if you haven't, go enable two-factor authentication. It's one of the most important things you can do. And so, that's the one non-open source security thing I'm going to touch on today. But otherwise, we're going to spend the rest of this session focused specifically on open source security. So let's get on to that. So kind of the first step is, there's a saying in security that you can't secure what you don't know you have. And that's why we want to start with identify. Our friend Hubot here says we need to find all the things. But in the context of open source security, what are all the things? Well, there's a couple of things that we want to identify. The first is, what are the open source components we're using? If we don't know what open source components we're using, we won't know what vulnerabilities we're exposed to, and the risk that leads to. So that's the first thing. Let's get our inventory of open source. Then we want to understand, what are those vulnerabilities? How severe are they? So that we can start making some kind of intentional decisions about, does this vulnerability really affect me? Do I need to upgrade? In what situations might this be an issue? And the other thing that, might surprise you a little bit to talk about in this category is the other thing that we might want to identify is, what is our security policy that we want to share about our projects? And this is particularly important if you have open source projects where you kind of want to set some expectations with the people consuming your projects of how you want them to report security issues. What are your supported versions? And how you're going to handle those security issues when they're raised. And so we're going to be looking at some of the features that GitHub has that is going to help you with these steps. And so, it's demo days. So let's jump straight into demos and look at the things that we can do to help identify. Okay, so the first thing I want to do is show how we can detect the open source that we're using in a project. So I have a repository here. It's my nothing enabled repository. So it has a bunch of code in it, but we haven't turned on basically any of our security features in this repository. So the first thing I want to do is go and start building up some knowledge of what are the dependencies we have. So I'm going to jump into the settings tab. And we're going to go down to security analysis. And the first thing I want to do here is turn on dependency graph. This will generally be on by default for public repositories, but it is something you'll have to opt into for any private repositories you have. So I'm going to go ahead and hit enable here. And so let's look at what that does. So if I jump over to the Insights tab here, and go to dependency graph, you'll see that what we now have is an inventory of everything that this particular repository depends on. So it's analyzed our package lock.json file, and you'll see, pretty quickly it's discovered that this project has, just over 1,300 dependencies. And so we've worked out what each of those dependencies are, the particular version. We can drill in here to see kind of what the dependency tree looks like for that. If you are the publisher of an open source project, you can also see, what's depending on you. But this is kind of our first step to all of the other security experiences, is having this base set of information about our dependencies. And to just fill you in on how this works, is what's happening is when this feature's on, as you're pushing commits up to your repository, we're analyzing the different package manifests for our supported ecosystems that are in those commits and building up, analyzing those package manifests and building up that graph of what you depend on. And we're keeping that up to date as you push up new dependencies. So the other thing that we want to look at here from an identification perspective is this is great at a single repository level, but what if we want to understand what our security issues are across the whole organization? And we just released this feature. It's only available for GitHub Advanced Security customers, so I just need to point that out. But this is up at the organization level, where we can now go and see for the set of repositories that we have in an organization, what are the different security features we have turned on and off. So, with dependency graph, and I'm going to show the alerts part of this in a minute, we have Dependabot. So I can see here what is the ratio of projects in this particular organization that have this feature turned on or off. But more importantly, I can also see what are the individual results. So I filtered here to repositories that I created. This is just a testing organization we use. And in fact, here is that repository I was just in. And we can see that over here, these are the number of vulnerabilities, that are active vulnerabilities that exist for each of the repositories from Dependabot Alert. Now, because I'm focused on open source security for this session, it's Dependabot alerts that we're going to be digging into in more details. But you'll also see that we are raising the similar information from our other security tools, such as secret scanning, which is looking for secrets that have been committed into your repository, as well as code scanning, which is our static analysis tool that can run queries over the code and identify security and non-security issues. So, with Dependency Graph, we now have the inventory. With Security Center, we can see an overview of the risks that exist across the organization. But you'll recall when I was talking about identify, the other thing that we may want to do is share what our security policy is for a particular repository. So let's take a look at how you would set one of those up. I'm back in that same repository I was in before, our nothing enabled repository, and I'm in the security tab on the overview sub-tab. And so you'll see here, security overview, we've got an orange icon that's saying we don't have a security policy set up. And I can go ahead, click here and say, I want to set up a security policy for this repository. And this is basically creating a security MD file in the root of the repository. We pre-populate that with an example. So in this specific example, we're communicating, what are our supported versions for this particular project. But then most importantly, we're telling people how we want them to report a vulnerability. We may not want them to go and open a public issue which might disclose that there are vulnerabilities before we've had a chance to create a patch. So often here we might direct them to some specific security email address where we want them to report issues, or provide them with some other secure channel of giving that information. From here, I can simply commit this in, and it's now part of the repository. You can create these on private repositories if you want to share information internally for internal vulnerability reporting. But where it's most useful is going to be in your public repositories, where you want to explain, for this open source project, what is the process you have in place for reporting security issues. So focused, mainly in identify there. What I want to do now is kind of shift and talk a little bit more about, how do we protect? Because identification is useful. We can go find the vulnerabilities we have. We can start working through those and resolving existing vulnerabilities. But really what we want to do is prevent new open source vulnerabilities from coming into our project. So let's look at a couple of techniques that we can use to achieve that. So if I jump over and talk about protect, how do we go about protecting? And there's two techniques that I'm going to talk about today. The first is reviewing changes to our dependencies as part of our normal processes around reviewing pull requests. This is, most projects are using a pull request model, particularly for contributors, outside of the project, but most people are also using pull requests even for core contributors as an opportunity to have a discussion and review that code. So it's important for us to incorporate reviewing changes to our open source dependencies into that existing review process. But the second technique I wanted to talk about here is proactively updating our dependencies, even when they may not have known security vulnerabilities. And you might be wondering why. Is there anything wrong with only updating a dependency when there is a known vulnerability? And, at a minimum, that is, that is your minimum bar. But there are advantages to updating proactively. Firstly, projects don't always disclose that they have vulnerabilities. Sometimes they'll find a security issue as part of their normal development flow. They might be implementing a feature and find a vulnerability in a related area. Someone might have opened an issue and they just went and fixed it. We've added functionality to make it easier for projects to disclose those vulnerabilities, and I'm going to show that a little bit later. But that still doesn't guarantee that all vulnerabilities will be disclosed. So proactively updating your dependencies to keep them on newer versions is one way of helping ensure that you're picking up those fixes that may not have been disclosed. But there's a second, possibly more important reason, which is, if we go back to kind of one of the earlier points I made, if we assume that it's not a matter of if, but when a vulnerability is going to be raised, then what you don't want to be doing at a point in time when you're trying to, quickly resolve potentially a critical vulnerability is trying to upgrade your dependencies across, multiple major versions. If you're not proactively updating, then you can be in a situation where, now to apply the fix to resolve this vulnerability, you have a significant amount of engineering work that you have to do. And it's going to be a time where, you're under pressure to fix this vulnerability, and having to, do that in that situation isn't productive. If you're, regularly doing this and keeping your dependencies up to date, then when this vulnerability comes out, maybe you have to go up one minor version or even just a patch version, but it will be much easier for you to respond to that vulnerability. there's a saying, if something's painful, do it more often to make it less painful, and this definitely falls into that category. So I want to show a couple of GitHub features that help in both of those scenarios. One is catching the introduction of vulnerable open source dependencies, and then also the ability to proactively update. So let's jump in and take a look at those. So let's look first at how we're going to find vulnerabilities that are being introduced. So I'm in it's actually a fork of that previous repository. This one does have some security features already turned on. The feature I'm going to show you is dependent on having dependency graph turned on, because identify is really the key to a lot of security. And if we look in this repository, you're going to see that we have 3 open pull requests, all created by this person, William Bartholomew. Not entirely sure he can be trusted. So let's go in and take a look at the changes that he's introducing to this project. So if I open the first one, you can see I'm a great developer. I provided no description on the PR, but it's blockchain related, so it's definitely cool. Let's jump over to the files changes here, and you can see that what I'm doing here is I'm making some upgrades to our dependencies as part of updating our blockchain library. And there's a feature that's in pull requests called rich diff. And where you might have seen this previously is an ability to see a rich difference for changes to Markdown files. So the same capability exists on Markdown files. But what we've done with a feature called dependency review is also expanded that to support package manifest files. And so if I click on the rich diff here, this is the package JSON itself. You can see this is relatively uninteresting. It's told us that we've updated to version 6.0. But there could have been a lot of transitive dependencies that change. This is a major, it was version 5.0 and it's now 6.0. So there were probably a lot of transitive dependencies that changed as part of this upgrade. And if we look at the changes to the package lock, you can see that there was actually 19,000 changes, 4,000 additions, 15,000 deletions. So there's a pretty insignificant set of changes to our dependencies here. So let's take a look at the rich diff for this one. And here we can see a much deeper view of what was going on. Here's dependencies that were added. Here are ones that were updated. We can get a little bit of insight into how many other people are depending on those packages, which might help give us confidence about those packages. We can see some license information. But you'll see what we've done is we've pulled this one to the top, where this particular version of this dependency actually has a vulnerability. In this case, it's a low severity vulnerability, so I might not be too particularly worried. I can drill in here and see the GitHub security advisory about this vulnerability, so I can see, is this a scenario that I'm worried about in my application? This comes from the GitHub Advisory database, which is a database of security vulnerabilities that we maintain and make available for free under a Creative Commons license. And so in this case, I might say, I'm relatively happy with this pull request. This seems pretty low risk. I don't see this being exploited in my application. So I'm going to go ahead and approve that pull request. If we go and look at one of these other pull requests and do a similar thing, we had some code changes here. I'm going to jump straight into the package lock file. We can see that the situation here isn't so rosy. We have multiple high severity vulnerabilities across multiple packages. And if I look at this one, this is a remote code execution vulnerability. So that could be a relatively serious risk to my application. And so at a glance, as part of our normal process for reviewing a pull request, we can go and see what is the impact of this change to my dependencies, what vulnerabilities are being introduced, and then can make a more meaningful decision about whether to accept that risk or not. So that's the reviewing of incoming open source changes to a project. But the other technique that I mentioned was the proactive upgrade of dependencies. So let's take a look at how we could set that up and some of our options there. So I'm in that same repository. I'm over on the Insights Dependency Graph tab, which is where we see our list of dependencies. And you can see here that I have a Dependabot tab. And if I go here, it's telling me that I don't have version updates configured. Now, Dependabot has kind of multiple sub features. There's Dependabot alerts, which we'll talk about in more detail in a minute. But there's also security updates and version updates. Version updates is the capability to do that proactive upgrading of dependencies. So this doesn't care if a dependency has a vulnerability or not. This is all about just keeping up to date on our dependencies. And so to set this up, very similar to the process that we went through for creating a security policy, is we can go in, click Create Config File. This is going to open up a Dependabot configuration file. I'm not going to go through this in complete detail and explain kind of every single configuration option. There is a link to the documentation here where you can go and learn about the different configuration options. But what this gives us the ability to do is configure multiple update policies for this particular repository. So what I could do is I could say, well, my NPM, I want to update all of my NPMs. I want you to look in this root directory of the repository for the NPM manifests. If I was in a mono repo, maybe I want to scope to a certain directory, or maybe I have a set of tools in one directory and the application source in another directory, and I want to focus this on the application source directory. So I could provide some scoping here. And I can set up a schedule. How often do I want Dependabot to look for packages and to send pull requests? There's other configurations where you can put constraints around, for instance, version ranges. And you can have different update policies in here. So you could say, update the things in this directory on this cadence, update the things in this directory on this other cadence. So you have a lot of control here. And Dependabot's going to go in on that cadence, see if any of your packages need to be upgraded, and then it's going to create pull requests to apply those upgrades for you. And you also have control over how those pull requests are tagged, who they're assigned to, and things like that. So these two techniques can both be used in conjunction with each other. You can have Dependabot version updates going in and applying proactive updates, as well as when developers are adding new dependencies or applying their own updates, you can go in and review the impact of those changes. So let's jump back to the slides. So those are the kind of the two things around protect. The next area I wanted to talk about is detection. So at this point, we know what open source we're using. We know what vulnerabilities already exist. And we just talked about processes that we can have in place to prevent vulnerable open source from being introduced. But unfortunately, new vulnerabilities are going to be discovered in the components we're already using. A component could have been in our source code base for 4 years, and a new vulnerability is discovered. They publish an advisory saying, we've found a problem in this old open source component, and now you need some way to detect that has happened and be able to react to it. Now, of course, I could go and look at each of my repositories every day, every week, every month, and see if new vulnerabilities have been created. I don't know about you, but that doesn't sound like a particularly fun use of my time. And so luckily we have Dependabot alerts who can tell us about when new vulnerabilities have been detected. And we also have Dependabot security updates, which is kind of the reactive version of dependency version updates, Dependabot version updates that can send us a pull request to upgrade vulnerable dependencies to non-vulnerable versions. So let's take a look at how we can set up both of these features. Okay. So I'm back in this nothing enabled repository, and I'm in the repository settings, and we have security analysis, and I already turned on dependency graph, so I'm just going to hit refresh here. Okay, so we're in the security analysis configuration, and you can see that we have, I turned on dependency graph before. We also have Dependabot alerts and security updates. So I'm going to go ahead and I am going to turn both of these on. There are some dependencies between these, so if you go and turn one on, it will automatically turn the other required features on. So we have all three of the dependency open source related security features enabled now. So let's go back to our security tab and take a look. So if we look here, Dependabot alerts, we now have 13 alerts. And so if I go in here, this is telling us for the open source that is already in our default branch. You'll recall dependency graph went and detected what we were using. Dependabot alerts has taken that information and compared it against the vulnerability database, which is fed from things like the National Vulnerability Database, to determine which of the things that we're using have vulnerabilities. These are categorized into severity based on the score that they were assigned. And these are curated by the GitHub Security Lab team. And so if we go in look at one of these, we can see, to resolve this particular one, we would need to upgrade to version 602. We can learn about the details of that severity. Now, we might look at this and say, look, this actually isn't an issue in our environment. So I do have the option to go in and dismiss this particular alert. Some of these I don't necessarily recommend using, but sometimes it's better to be honest than to kind of sweep things under the rug. I could come in and say, yeah, I just don't have time to fix this. But in some cases, you look at a vulnerability and the risk is acceptable. Maybe the application is running in an environment where that can't be exploited. Hopefully not, but there is a possibility that an alert for some reason is inaccurate or incorrect. This is definitely a signal that we look at to make sure that the information we're giving you is accurate. Or maybe that, yes, this component has a vulnerability, but we're not using the particular function in it that is vulnerability. It might be a particularly large library with lots of different capabilities, and we're only using one small part of it, and so we're not affected by this vulnerability. Generally, I would recommend just go and upgrade anyway. One of the reasons for that is just because I'm not using the vulnerable functionality today doesn't mean that someone else isn't going to come along and start using vulnerable functionality in it tomorrow, next week, next month. So you're generally better off, keeping those versions up to date. But in some cases, this could be a valid option. So that's our ability to dismiss alerts. And they may not have come through yet. I can manually kick one off, I think. What Dependabot security updates will do is go ahead and proactively create pull requests when it can to upgrade these vulnerable dependencies to their non-vulnerable versions. And that's a process that will kick off periodically and you'll receive those vulnerabilities. The other thing is Dependabot alerts have the ability to notify you. This is something that you might have seen some angst about in the past of Dependabot alert telling me constantly that I have problems. This is an area that we've already done a number of fixes in or improvements to make Dependabot more precise about what it tells you and when. And we also have some further work coming up in this that will help bring that noise down and give you a little bit more control. But I just wanted to show you kind of some of the setup around that. So if I go to Dependabot, back to Dependabot alerts, sorry, I'm going to go into settings, security analysis. Down here, we can configure who has access to the alerts. By default, it's the organization and repository administrators, but I can give additional people access to the alerts, and that will also give them access to the notifications. And you can come in and configure your notification settings for Dependabot alerts. So you can choose how you get the notifications, as well as, do I want an email as soon as the vulnerability is found, or do I want a digest, and on what frequency? And you're going to see, as I mentioned, more improvements to some of this notification capability in the future. Okay, so At this point, we've identified what open source that we have. We have looked at proactive ways that we can prevent new open source being introduced. We looked at how we can detect vulnerabilities that are responding and detect new vulnerabilities in existing open source. And then the last thing I wanted to talk about is, how do we go ahead and respond to vulnerabilities that we've been alerted to for our open source projects? I'm seeing a question here that I'll touch on before we kind of move on, which is, how do vulnerability notifications work for private repositories? And so one of the reasons why dependency graph capability is opt-in for private repositories is, by default, we're not looking at any of the data in your private repositories. When you opt in to dependency graph, you're effectively giving us access to read the changes to the package manifests as they are flowing into your repository. And so we're looking at specific file types. So we're going and looking for just package.json files, package locks, pom.xml for Maven, gem files for Ruby. We have a whole set of criteria of what files we look for. And we're going to look at just the content of those for the purpose of working out what your dependency graph is. That information is private to your repository. It's not used outside of that context. And then once we have that set of dependencies, we can then match that to the alert data and share that just back with you. So the information about what alerts you have for a particular repository is only accessible to people that are administrators of the repository or that you gave explicit access to in that screen that I showed earlier. So you have a lot of control over whether you want us to look at those files at all, as well as who has access to the information resulting from it. So I hope that helps address any concerns you have there. You'll find a lot more detail in our documentation up on docs.github.com. And if you have specific questions beyond that, you can reach out to support at GitHub to discuss your specific scenario. So in this last section, I want to touch on some of the tools that we provide around making it so maintainers of an open source project can disclose vulnerabilities to the people that are consuming their project and collaborate on fixes. So I'm going to jump straight back into a demo, and we're going to look at what is called maintainer security advisories. I have a public repository here, and I'm back on that same security tab. And if we look at security advisories here, you'll see that I don't have any draft security advisories. This is obviously a very secure project. I'm going to go ahead and create a draft security advisory. And here I can basically define the vulnerability that has been discovered. So I could say that this was an NPM project. The package name is this. I could say that everything before version 1.0 is vulnerable and the fix is in 1.0. I can categorize what the severity of this vulnerability is. So I can say, it's moderate, or I can go in, if I'm more familiar with, for instance, vulnerability scoring, I could use the common vulnerability scoring framework. And there's documentation there where I can go in and actually select all of the different inputs into calculating a CVSS score. So I could say, look, this can only be exploited locally. It's a complex attack. You don't need any privileges. User. So I'll go through and just pick. Maybe it's a confidentiality issue and it doesn't affect integrity or availability. And what this will do is go in and calculate the CVSS score here as 5.5 and assign the category of moderate to that. There's also another scheme for describing software weaknesses, which are the common weakness enumerator. So I might say that this is an information disclosure issue. And so I could say, perhaps the bug here is that sensitive information such as your token gets included into sent data. So I can choose that categorization here and I can assign multiple of these. And then because GitHub became a CVE numbering authority, we have the ability to actually go in and say, I want the ability to request a CVE for this, or if I've already been assigned one, I can choose that and provide those details. Now I can go ahead, write the title of my vulnerability, describe the impact, workarounds, etc. And I must be missing a mandatory field here somewhere. I think. What have I missed here? Okay. So I'm going to go ahead and create this. This is just a draft security advisory within my repository. Only these people can see it. But what's important is I can now add other people to collaborate on this. So, maybe there's a security professional that I'm working with and I want to give them access to this advisory. We can have discussion on the advisory back and forth. And I can also start a temporary private fork where we can collaborate on the fix with these collaborators without disclosing the vulnerability publicly until we have a patched version in place. And then once we have our patch, we've written up our advisory, we've refined the text, we're pretty happy with it, we can request a CVE and eventually publish this advisory to be public as part of the repository and have that appear as part of the GitHub advisory database. So this is a very easy way for people that own open source projects in the context of where they're already working on the project to be able to collaborate on vulnerability disclosures in a private way and then publish that information to the consumers of the projects. And then this is going to flow back into basically all of the previous features I've shown you in this session, such as the Dependabot alerts, security updates, and into dependency review. So now that consumers of this project have this high quality curated data directly from the project maintainers available right for them as part of their development workflows. So you can see I'm very excited about this. This is really helping us close the loop between those different phases of open source security. So at this point, we've gone through, those 4 security functions from the security framework earlier. We learned how that we identify the open source we're using and the vulnerabilities it has. We've learned some techniques such as dependency review and proactive updates to protect vulnerable open source from being introduced. We looked at how we can detect and fix new vulnerabilities with Dependabot alerts and Dependabot security updates. And we just learned how we can respond to vulnerabilities we've found in our open source projects using maintain a security advisory. We've been able to go in and turn most of these features on. I didn't fully configure them, but we were able to go through all of these features in just under an hour. So as you can see, it's pretty easy to get started, start learning about what vulnerabilities you're exposed to, fix them, get proactive updates and security updates in place. A lot of them, it is that easy to just go in and click the enable button. You'll find a lot more information on docs.github about how to turn these features on, how to configure them if you want to get in more detail. But I encourage you to go out, try these features and see how they help you improve the security of your open source use. That's all I have today. So I wanted to kind of thank everyone for joining us, and hopefully this has given you some concrete tips that you can go and apply to making your open source more secure.